Hi, my name is Pavitran. My metric number is 194193. So topic today is first law of thermodynamics.
My name is Keshwathaman Krishnan. My metric number is 193609.
Hi, my name is Meghavarman and my metric number is 193499.
And me, myself, Kirubana Vasu, my metric number is 194896.
So, hi guys. So, the first law of thermodynamics is related to the principle of conservation of energy, which can be represented in the mathematical equation delta U is equals to Q minus W, where delta U is equals to internal energy, Q is equals to the heat supplied to the system, and W is equals to the work done. The important concept in thermodynamics is the thermodynamic system, a precisely defined region of the universe under study. Everything in the universe except the system is known as the surroundings and is separated from a system by a boundary, which may be a notational or real, but which by convention delimits a finite volume. Exchanges of work, heat or matter between the system and the surroundings take place across this boundary. Thermodynamics deals only with the large scale response of a system, which we can observe and measure in experiment, such as heat and steam engines, for which the study was first developed. So that's all from me. Thanks.
Guys, so let's consider the first law of an isolated system. That means heat and energy can neither leave or enter the circle. Such system does not done any work, but we can imagine it with a certain energy inside it, namely delta U, which depends on the kinetic of the molecular system and also the system's temperature. The internal energy is the same with potential energy because it has the property that does not work, but it has the same potential to do the work. So the first law describes that the internal energy of a system increase if the heat is added to a system. The first law can just show another way of the law of conservation of energy, as heat and work are another form of energy. If they go outside of the system, it will affect the internal energy of the system. So to ensure the efficiency of a machine, the heat loss to the surrounding should be low. And that's all from me. Thank you.
So as we know, the first law of thermodynamics had been explained by my friends just now. So from there, what we can see is actually the excessive heat loss will actually lead to a negative impact, for example, to a machine or something else. So what I am trying to tell from here, the first law of thermodynamics is very important to balance out the Earth's nature. For example, the Earth's core. Earth's core is very hot until the heat loss is given out is quite massive. So from there, the heat loss must not exceed its limit to prevent the upper surface of the Earth to be affected. So to prevent that, the internal energy used at the Earth's core for chemical purposes is much more higher compared to the heat loss. So it's balanced out that way. So that's a basic example of first law of thermodynamics applied to nature's environment. So on the other hand, if we look at the basic daily lives of human beings, the first law of thermodynamics is also applied in everyday actions. For example, if people take bath and also the melting of the phenomenon of melting of ice, it is also considered to be under the principle of first law of thermodynamics. So from here, we are going to try to explain the further details of first law of thermodynamics using an application which leads to engineering field. So the application tool that we are going to use for this presentation is actually our iron box.
Hi guys. Now, as my friends explained to you about the first law of thermodynamics. Okay, first law of thermodynamics, which is consists of the conservation of energy. So now we are gonna take this iron box as the engineering material, which involves with the first law of thermodynamics, which is conservation of energy. Now I'm gonna explain about the parts of this iron box. Firstly, this is the plug, and this is insulated wire, and this is insulated plastic handle, and inside this we got the coil, which is a thermostat and also which will produce the heat energy, and this is the cast iron sole plate which will enhance the heat energy from the thermostat. Okay guys, now I'm gonna explain how the electrical energy is converted to the heat energy in this iron box. Firstly, from this plug, the electrical energy will be transferred through the power supply to through this plug, and it will flow through this insulated wire. The insulated wire is to prevent the electrical energy to come out of this wire, and then the electrical energy will be transferred inside the iron heating element, which is heating element, which is the coil, and the coil is heated because of the resistance of the electrical energy which is flow through the heating element, which is due to the thermostat will increase the resistance, and then the coil also, the heating element which is the coil will resist, due to the resistance it will started to heat up, and then the heat will be enhanced at this part of the cast iron sole plate. The sole plate will enhance the heat and will produce a heat surface for us to use the iron, to use for ironing purpose. And then the electrical energy will be converted to the heat energy inside, and it will be produced to the usage of the people. And then here is also the electrical energy converted to the light energy, which will indicate the iron box heating. Okay, that's all the simple explanation of this iron box, how the electrical energy converted to the heat energy, and then the heat energy used in this iron box. Thank you.